test paper first. The first question of section first is of single correct question, and the question states functional group present in damascenone compound responsible for smell of rose is. And here is the structure of damascenone. It is given a 6-membered ring. Here 2 double bonds are given, 1 methyl, 2 methyl again, and 1 ketonic group, 1 double bond. This is the structure of damascenone is given. And question is asked, if functional group present in damascenone is A option ether, B option ester, C option ketone, and D option is alcohol. When carefully look about this question, you will find that carbon-carbon double bond, this is called as alkene. Again carbon-carbon double bond, this is called as again alkene. This is carbon-carbon double bond, it is alkene. And CCOC, CCOC, this attachment is called as ketone. This attachment is called as ketone. So the answer will be C. Answer will be C. From this question, you must also know about the attachment of ether, ester, and alcohol as well. Whenever you have to find the attachment in ether, always be careful, it will be COC type. Here, the C will attach to carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond, or aromatic ring 2. Here also, this C may be carbon-carbon single, carbon-carbon double, carbon-carbon triple, or phenyl aromatic ring may be attached over it. It may be of type CS3, CS2O, CS2, CS3. It may be of type this. It may be of type this. Here, carbon-hydrogen single bond may also be considered. Okay. In ester, the attachment will be of like this. One part of oxygen is attached with Cu and another part is attached with carbon-carbon single, double, triple, or aromatic part. It may be of like this. 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 But the attachment should be COOC, alcohol. Whenever question is asked about alcohol, you must know the attachment of alcohol. That is, OH group is attached with single bonded carbon, and this attachment is called as alcohol. And as I told earlier, the attachment in ketone is like this, CCOC. This attachment is called as ketone. This attachment is called as alcohol. This attachment is called as ester, and this attachment is called as ether. So in damascenone, the attachment is like ketone, so answer will be C. The next SCQ question is second. It states that the compound which is not homologue of malonic acid is. To solve this question, you must know the structure of malonic acid. The structure of malonic acid will be like this. Will be like this. This is called as malonic acid. This is called as malonic acid. Okay? And option is oxalic acid, acetic acid, succinic acid, and adipic acid. As structure is not given in our question and common name is mentioned, so to solve this question, you must know about the structure of these acids. The option A, oxalic acid, is like this. This is called as oxalic acid. Second, acetic acid. Acetic acid will be like this. This is called as acetic acid. Third, succinic acid. succinic acid will be like this. This is called as succinic acid. And last, adipic acid. Adipic acid will contain 6 carbon with dicarboxylic acid, and this is the adipic acid. This is the adipic acid. And question is asked, the compound which is not homologue of malonic acid is. As you have the structures, now you can easily identify which is not the homologue of malonic acid. Go to the basic. Homologues are those compounds which have same functional group, but differ in CH2N unit, CH2N unit. Those compounds which have same functional group but they have difference of CH2N units, they are called as homologue. So here in malonic acid, 2 carboxylic acid groups are present. In oxalic acid also 2 carboxylic acid is present. In succinic acid also, and in adipic acid also 2 carboxylic groups are present. But when you carefully analyze about the structure of acetic acid, here only 1 carboxylic acid group is present. And here along with carboxylic acid 1 carbon is present, that is this compound contain 3 carbon, and here this compound will contain 2 carbon. But the difference is not of CH2N unit, but the difference is of CO2 unit. And if the difference is of CO2 unit, then this compound will not be considered as the homologue of this malonic acid. So our answer will be acetic acid, and it will be option B. Now the third question is again of SCQ. It states that total number of primary carbon present in cyclic structure glucose is. The structure of cyclic glucose which is mentioned in the question, and it is like this. The structure is given like this. Okay, this is called as glucose, cyclic structure of glucose. Question is the total number of primary carbon present in cyclic structure glucose is, and here is the structure of glucose. Option is 6, 3, 2 and 1. When you have to solve the nature of carbon, that is whether it is primary, secondary, tertiary or quaternary, you must know about the attachment with other carbon atom. If the carbon is attached with none or 1 carbon atom, if carbon is attached with none, that is it may be attached with nitrogen, oxygen, sulfur, halogen, they are considered as non-carbon. If the carbon is attached with none or 1 carbon, this is called as primary carbon. But if carbon is attached with 2 carbon, this is called as secondary carbon. If the carbon is attached with 3 carbon, this is called as tertiary carbon. And if carbon is attached with 4 carbon, it is called as quaternary carbon. So when question is asked how many primary carbon is present in this molecule, so think about the attachment of this carbon. If you carefully analyze this carbon, it is attached with 1 oxygen, 1 carbon and 1 hydrogen. So if this carbon is attached with only 1 carbon, so it is called as primary carbon. Think for this one. This is attached with 1 and 2 carbon, 1 oxygen and 1 hydrogen. If it is attached with 2 carbon, it will be considered as secondary carbon. For this, it is attached with 2 carbon, 1 O and 1 H. It is also secondary. Here again, it is 1 oxygen, 1 hydrogen. If attached with 2 carbon, it is also secondary. Here, it is attached with 1 carbon, 2 carbon, 1 hydrogen and 1 oxygen. It is also secondary. And this carbon is attached with one carbon, one oxygen and two hydrogen, so it will be of primary nature. So in glucose there are 1, 2, 3, 4 secondary carbon and 2 primary carbons are present. And if question is the total number of primary carbon of this glucose, so answer will be C, as it has only 2 primary carbon. So answer will be C. Now the question is fourth, again of SCQ, in which question state which among the following is a saturated molecule. Again in this question common name is mentioned. So to solve this question you must know about the structure of these common names. First is allyl alcohol. The structure of allyl alcohol will be like this. This is called as allyl alcohol. Second is vinyl chloride. The structure of vinyl chloride will be like this. This is called as vinyl chloride. And the structure of acetone, which is mentioned in option C, will be like this. This is called as acetone. And last structure is of chloroform, which is mentioned in option D. This is chloroform. Again, I read about the question. The question is which among the following is a saturated molecule. So you must know about the definition of saturated molecules. The saturated molecules are those molecules which have no tendency to further add any molecule. That is, they are simply those molecules which are single bonded. The multiple bonded compounds have tendency to add molecules and to form saturated one. So if question is asked about the saturated molecule, you must think about those molecules which have only single bond. It may be cyclic or it may be acyclic. So in option A, here carbon-carbon double bond is present, so we can add hydrogen molecule over it to form normal propanol. So this is unsaturated. This is unsaturated. Here also carbon-carbon double bond is present, so it is also unsaturated in nature. This molecule also have carbon-oxygen double bond, so this will also be considered as unsaturated molecule. But in this molecule, chloroform, there is no such carbon-carbon double or carbon-carbon triple or any type of multiple bond, so this will be called as saturated molecules. So answer will be D. You should also be careful when we think about the saturated unsaturated molecule and also saturated and unsaturated hydrocarbon. When question is asked about saturated and unsaturated hydrocarbon, then molecule will only contain carbon and hydrogen. If molecule only have carbon and hydrogen, then such molecules are called as hydrocarbon. But if molecule have carbon, hydrogen along with any other atom such as nitrogen, oxygen, sulfur or halogen, then they are called as derivative of hydrocarbon. So this molecule is derivative of hydrocarbon. This is also derivative of hydrocarbon and this is also derivative of hydrocarbon. But think about this molecule CH3, CH double bond, CH2. This have only carbon and hydrogen, so it is simply the hydrocarbon. Similarly, if question is in the form of alkyne, so if this, in this alkyne also there is only carbon and hydrogen, so this molecule is also called as unsaturated hydrocarbon. But for this propane, this have only carbon and hydrogen, so and with no multiple bond, so this is called as saturated hydrocarbon. The definition must be crystal clear, which is called as saturated, which is called as unsaturated hydrocarbon, and which is called as unsaturated hydrocarbon derivative and saturated hydrocarbon derivative. The next question is fifth, which is again of SCQ. In this question, I have asked which compound have same hybridization for each carbon as that of benzene. Again, in this question, common name is mentioned. So to solve such question also, you must know about the structure of this common name. The first option is cumene. The structure of cumene will be like this. when benzene is attached with isopropyl group, this is called as cumene. The second is cinnamic acid. The structure of cinnamic acid will be like this. This is called as cinnamic acid. Third, the structure of aspirin. The structure of aspirin is like this. Benzene is attached with OCOCH3 and here ortho position have COOH group. This molecule is called as aspirin. And last, acetanilide. The structure of acetanilide is like this. Benzene is attached with NHCOCH3 group. This is called as acetanilide. The question is, which compound have same hybridization for each carbon as that of benzene? The structure of benzene will be like this. The benzene is like this. If you are asked about the hybridization of any atom in molecule, you must know about the sum of sigma bond plus lone pair of electron if that atom have. If the sum of sigma bond and lone pair of electron equal to 2, then hybridization will be sp. And if it will be 3, the hybridization will be sp2. And if the value is 4, the hybridization will be sp3. The concept is very simple. In this question, you must know about the structure because the difficulty level of this question is only the structure. Finding hybridization is not a big deal. You can easily find out the number of sigma bond and lone pair. And if the question is asked about the carbon and you know that carbon have no lone pair of electron, so you must know about the sigma bond. The hybridization of carbon in benzene is sp2 for each carbon. So in this question, you have to find that each carbon in the molecule will be sp2. For the benzene, each atom is sp2. So leave it. Here the hybridization is sp3. So this will not be our answer. Here the hybridization is sp2, 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 all sp2. So this will be our answer. Here the hybridization will be sp2, 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 sp2. But here sp3 hybridization is there. So sp3 hybridization, this will not be our answer. Here also sp2, 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 again sp2. But this carbon have sp3 hybridization. So this will not be our answer. So the molecule in which each carbon is sp2 hybridized is cinnamic acid and our answer will be B. Now the question is 6, which is again of SCQ. The question states which molecule is not planar in C. First, cyclooctatetraene, B, cyclobutadiene, C, naphthalene, and D is anthracene. Again, in this question, you have to remember the structure of these common names. So, first, cyclooctatetraene. Cyclooctatetraene. The structure will be like this. Second, cyclobutadiene. Cyclobutadiene. The structure will be like this. C, naphthalene. The structure of naphthalene will be like this. This is called as naphthalene. And last, the option is anthracene. The structure of anthracene will be like this. The structure of anthracene will be like this. And this is the structure of anthracene. So first observation is this. If an atom have sp2 hybridization, then it will be planar in C. So by first observation, all molecules are thought to be planar. But always be careful in these two molecules, this one and this one. Always be careful about these two molecules. By first observation, these two molecules are thought to be planar. But in reality, these two molecules are not planar in C. The real shape of this molecule will be like tub shaped. This will be like tub shaped. it will be like this. You can think about 1, 2, 3, 4 carbon, 5th is like this, 6th is like this, 7 is like this, and 8 is like this, and this is attached. So it will be like tub in C. The structure of cyclooctatetraene is not planar, but it is tub C. Tub C. And this molecule is also not planar in C. The hydrogen present over this position will disturb the planarity of this molecule. So, if you know about the reality of shape of this molecule, then only you will do such type of question. So, according to this, as you know about the structure, so your answer will be A. Now, the 7th question, which is again of SCQ. In this question, it is asked, which among the following is not aromatic compound? 4 structures are given. In first structure, here 5-membered ring is present, 2 double bond. Here again nitrogen double bond is mentioned. Here negative and positive part is mentioned. In second structure, a 6-membered ring. Here nitrogen is present, carbon-carbon double bond. Here C double bond O. Here again NH. Again यहाँ C double bond O is given. In C option, a 6-membered ring along with a 5-membered ring is mentioned. Here nitrogen is present. Here again nitrogen is present. Here C double bond O. Here again NH is given, and here also N is given. Here double bond NH2. Here NH, and here double bond is present. In option D, 6-membered ring is attached with another 6-membered ring. In between, no bond is present. It will be like this. And question is, which among the following is not aromatic compound? To think about the aromatic compound, molecule must have to fulfill 4 requirements. The 4 requirements are: first, molecule must be cyclic in nature. Molecule must be cyclic in nature. Second condition will be each atom of the ring. Each atom of the ring will be sp2 hybridized, sometimes sp hybridized. If molecule have more than 1 ring, then in that case at least 1 ring must have sp2 or sp hybridization for each atom. And third condition is molecule as a whole must be planar or nearly planar. Molecule as a whole must be planar or nearly planar. And for poly rings, at least 1 ring must follow these 3 conditions. And for total number of pi electron in the ring must have 4n plus 2 pi electron in number. Okay, if any molecule fulfill all these 4 conditions, then only we can see that such molecules are aromatic in nature. So for this, when you will make a resonating structure, that is A double bond V, C have negative charge. This negative charge comes over this position, and the resonating structure will be like this. The resonating structure will be like this, positive and negative. And if A double bond V, C have negative charge, then this carbon is also sp2 hybridized, and negative part contain 2 electrons. So these 2 electrons are also be counted in counting this 4n plus 2 pi electron system. So here system is cyclic in nature. Each atom is sp2 hybridized, molecule is planar, and total number of pi electron is 6. Therefore, this molecule is aromatic in nature. This molecule is aromatic in nature. Similarly, here also 2, 4, and this will be broken. You can also tautomerize this molecule to form this type of structure. Here nitrogen double bond, OH double bond, again this will be like this. So 2, 4, 6. This molecule is also aromatic in nature. Aromatic in nature. If you will think for this molecule, after tautomerization, this will come like this. This molecule will come like this. Double bond, NH, double bond, here nitrogen, NH2, nitrogen, double bond, here OH. So this molecule is also aromatic in nature. In previous question, I have already told that this molecule is non-planar in shape. Non-planar in shape. So this molecule violates this condition as this molecule is not planar. The hydrogen present over this position disturbs its planarity. So if this molecule will not fulfill these four requirements, so this molecule is not considered as aromatic, so it is non-aromatic. Non-aromatic molecule. So our answer will be D. Again, in this question, be careful and always try to remember two structure. One structure is this one, in which each atom is sp2 hybridized but molecule is not planar, and second is cyclooctatetraene. Cyclooctatetraene. Here each carbon is sp2 hybridized but molecule is not planar in shape. The real shape of this molecule is tub shape. Tub shape. So these two structures are non-planar, so they are not considered as aromatic in nature. Now the question 8 again of SCQ. In this question, I have to ask which compound have maximum angle strain. Maximum angle strain. In first option, it is given 3-membered ring with ketonic functional group. In option B, it is given 4-membered ring with ketonic functional group. In option C, 5-membered ring with ketonic functional group. And option D, 6-membered ring with ketonic functional group. And question is asked which compound have maximum angle strain. What is angle strain? The angle strain is the strain produced when a desired angle minus real angle. So if carbon is sp3 hybridized, to desired angle will be 109 degree 28 minute, but in reality it is 60 degree. In reality it is 60 degree. So the difference of these two, that is 49 degree 28 minute, is the angle strain. In this carbon, in this molecule, at this particular carbon, the angle is 1029 degree desired and real is 90 degree. So here the angle strain is of nearly 19 degree 28 minute. In this case, angle desired is 109.28 degree and real is 108 degree. So strain will be 1 degree 28 minute. In this case, the desired angle is 1028 minute and real angle is also 109 degree 28 minute. So the angle difference is 0. Never think that 6-membered ring have angle of 120, that is 120 degree. The cyclohexane will be like chair and board form. So the real cyclohexanone will be like this, and the angle will be 109 degree 28 minute. So the angle strain is 0. The definition of angle strain is the desired angle. The desired angle minus the real angle. This is called as angle strain. And if you will find over this position, so it will be half in this side and half of this side. So at real picture, it will be desired angle minus real angle by 2. Desired angle minus real angle by 2 will be the angle strain from this side and from this side. Okay. So in our question it is asked which compound has maximum angle strain. So the maximum angle strain will be 49 degree 28 minute in option A. So our answer will be A. If a question is asked about maximum, so this one, and if a question will be asked in minimum, so your answer will be D. Now the question is 9th again of SCQ. In this question, it is asked which compound is called as isooctane, and for structure is given. The structure 1 is like this, structure B is like this, structure C will be like this, and structure D will be like this. And in these 4 options, you have to find which compound is called as isooctane. Be careful about some common names. Whenever you have to see an alkyl, whenever you have to see isoalkyl, whenever you have to see neoalkyl, set alkyl, third alkyl, these common alkyl parts are always mentioned in questions, so be careful about these 5 alkyl parts. N-alkyl means N-alkene where state change hydrocarbon with hydrogen removed from first position. When isoalkyl, in isoalkyl hydrogen is attached from first position but second last carbon has one methyl group. For neoalkyl, hydrogen is removed from first position but second last carbon have 2 methyl group. Secondary alkyl, secondary carbon have removal of 1 hydrogen, and tertiary alkyl, that means tertiary hydrogen is removed. So these are some alkyl groups always be present in organic molecules, and this commonly used also. So if Cl is present over here, so 1, 2, 3, 4, 5, so it is called as N-pentyl chloride. If Cl is present over this position, 1, 2, 3, 4, 5, isopentyl chloride. If Cl is present over this position, 1, 2, 3, 4, 5, 6, it is called as neohexyl. If Cl is present over this position, it is called as sec-butyl chloride. And if hydrogen is present over this position, it is called as tertiary butyl chloride. So for iso, this particular position must be present. This particular position must be present. So this molecule is called as isooctane. If hydrogen is removed, then it is called as alkyl part. If hydrogen is not removed, then it is simply called as alkane. So butane will be like this. Butane will be like this. If hydrogen is removed from this position, it is called as N-butyl. If removed from this position, it is called as sec-butyl. If removed from this position, it is called as isobutyl. And if removed from this position, it is called as tert-butyl. And in case of alkane, this is called as N-butane, this is called as isobutane, this is called as neopentane, and if hydrogen is removed from this position, it is called as neopentyl. Always be careful. This molecule is also called as isooctane, and this molecule 2, 4, 6, 7, and here methyl. This molecule is also called as isooctane. But in common practice, this isooctane is used for knocking acid in petroleum. So this is most common isooctane. So always remember about this structure of this isooctane, because in many times you will be confused with this structure. So isooctane are both, but most common isooctane will be this one. So our answer will be A. Now the last question of SCQ. It is given, which among the following compound is considered as a spiral compound? Option A is like this. Option A will be like this. Option B will be like this. Option B will be like this. Option C will be like this. And option D will be like this. And this question, it is asked, which among the following compound is considered as spiral compound? So always careful in bicyclic compound. Bicyclic compound. Bicyclic compound is of three types. Bicyclic compound is of three types. First is called as spiro compound. First is called as spiro compound. Second is called as fused bicyclic compound. And third is called as bicyclo compounds. If same carbon is attached with another ring, so it is called as spiro compound. The number of carbon in these two rings may be different, may be same, no matter. But same carbon must have two rings. In such case, it is called as spiro compound. It will be like this. It will be like this. Okay? It will be like this. Fused bicyclic compound. In fused bicyclic compound, first and second carbon attached with rings. If two rings are fused with these two carbon, so this compound is called as fused bicyclic. It may be like this, it may be like this. This is called as fused bicyclic. And bicyclo compound. Bicyclo compound are those compounds in which if this carbon and this carbon is left, any other carbon is attached with this carbon. That is, ring is not formed this way or this way. You can form ring by this way. You can form ring by this way. You can form ring by this way. These type of structures are called as bicyclo compounds. So, if question is which among the following compound is considered as spiro compound, so this is bicyclo compound, this is bicyclo compound, this is spiro compound, and this is also bicyclo compound. So, our answer will be C. Be careful, if the hybridization of this carbon and this carbon is sp3, an angle will be NEET of 109 degree 28 minutes. So the structure will flip to get maximum stability. So this structure is this one and this structure is of this one. So be careful, the real molecule will be not like this, but the real molecule will be like this.